Hello all, once again, welcome to the LJ Institute of Engineering and Technology. Let's start with the our subject Mathematics 2, and today's chapter is series solutions of ODE, ordinary differential equation. Now you all know the simple general solution of ordinary differential equation of first order first degree, as well as you know the linear differential equation of higher order. Okay, so you know how to solve, how to find general solution for particular differential equation with constant coefficient as well as with variable coefficient. But now some differential equations could not be solved by that method of higher order differential equation, that shortcut methods, general method, variation parameter method, undetermined coefficient method. So some examples or some ordinary differential equation could not be solved by that method. So we have another method of series solution. Okay, so in this chapter we'll learn how to solve ordinary differential equation of second order by series method, that means by power series method. Okay, so let's start with the first lecture. In first lecture we will learn singularities of differential equation. If we know singularity of differential equation, then according to that singularities we can find the series solution. Okay, so to understand singularity, first we will understand what is power series. So an infinite series of the form sigma n is equal to 1 to infinity a n x minus x0 whole raised to n is equal to, if we put value of n is equal to 0 in this, so we have a0 is bracket whole raised to 0, that means 1, plus if we put n is equal to 1, so a1 x minus x0 raised to 1, so we have this. If we put n is equal to 2, we have a2 x minus x0 whole raised to 2, and so on. This is called power series in powers of x minus x0, because we have x minus x0 raised to 1, x minus x0 raised to 2, x minus x0 raised to 3, and so on. Okay, here this a0, a1, an, a2 up to so on are constants. So these are the constant, a0, a1, a2 are constant, and x0 is also constant, but it is fixed constant. We can say the center of the series, okay, is called center of the series, and x is our variable. This x is our variable. So before starting this chapter, you have to know about the power series, and we all are very familiar with the power series because we studied this power series in semester 1 also. Now in particular case, if we take x0 is equal to 0, that means center of the series becomes 0, then the infinite series of the form this sigma n is equal to 0 to infinity a n x raised to n, because this x0 is 0, so x minus 0 becomes x, so x raised to n. And if we put the value of n is equal to 0, we have a0, value of n is equal to 1, we have a1 x raised to 1. If n is equal to 2, so a2 x raised to 2, and so on, is also called power series, but this is the power series in power of x, because here we can say that x raised to 1, x raised to 2, and so on. Okay, so this is basic concept of power series. Now we will understand about the what is analytic function. Okay, so what is analytic function? A function f of x is said to be analytic at point x is equal to x0 if f of x has a Taylor series expansion about x0. Okay, we already studied this also in semester number 1. Okay, semester 1, the Taylor series expansion of f of x at point x0, that is in power of x minus x0. It is given by this. If you put n is equal to 0, 1, 2, 3, and so on, you will get that Taylor series. So if f of x is said to be analytic at point x is equal to x0, if f of x has a Taylor series expansion about x0, which is given by this, exist and converges to f of x for all x, okay, in some interval containing x0. So in simple sentence, if you want to remember the analytic function, what is analytic function? So you can remember this: a function is said to be analytic at point x0 if it can be expressed in power series near x0, because we know that Taylor series is also power series. Okay, so simple. What is analytic function? That you have to just remember. And The polynomial function like e raised to x, sin x, cos x, sin hyperbolic x, cos hyperbolic x, all are analytic everywhere. Okay, that means you can find the Taylor series for this function at any point for all x, okay, which are exist and converges also. Similar way, rational function is analytic everywhere except at those value of x at which the denominator is 0. Okay, the value of x where the denominator becomes 0 for this type of rational function p of x by q of x. Okay, so if for a value of x this becomes 0, at that point this function is not analytic. Other than each and every point the function, this rational function is analytic. Okay, so this is the definition of analytic function. If it is asked in examination, so you have to write down this definition, or you can write this simple sentence also. But first I prefer write this definition. Okay, now after understanding what is power series and what is analytic function, we have the most important point, that ordinary points and singular point. So what is ordinary point and what is singular point, that we have to understand. That means singularity of ordinary differential equation. So let's start. So consider a homogeneous second order linear differential equation with variable coefficient that already you studied in higher order differential equation, which is given by this. This is our second order linear differential equation ODE with variable coefficient, because we have P0 of x, P1 of x and P2 of x are our polynomial or the function of x. So this differential equation is with variable coefficient. Okay, say equation number 1. Now if we divide this equation number 1, why we are going to divide? Because if we want to find ordinary point and singular point, that means if we want to find singularity, then coefficient of d square y by dx square must be 1, only 1. Okay, so we have to divide equation number 1 by p0 of x. So we will get d square y by dx square plus p1 of x divided by p0 of x divided by dx plus p2 of x divided by p0 of x y is equal to 0. Now we will say this and this, we will denote this as capital P of x and this is our capital Q of x. So we have this equation number 2 where p0 p of x, capital P of x is given by this and capital Q of x is given by this. So now we will consider this equation to find singularity. Okay, now so whenever this kind of equation given, so you have to just divide the equation with coefficient of this y double dash. We can say that y double dash. Okay, now first definition of ordinary point. So a point x is equal to x0. This x0 may be any real number or any complex number also in some cases, but we'll just consider any number. So a point x is equal to x0 is called ordinary point of the equation, this equation number 2, which we already derived, if both the function this p of x and q of x are analytic at x is equal to x0. That means in this equation, if p of x and q of x both are analytic, that means you have to remember finite. Okay, just write down analytic, but in your mind you have to just remember finite. So if p of x and q of x both are finite at point x is equal to x0, then this point is called ordinary point. Simple. And second definition is singular point. So in singular point, what is the definition? That a point x is equal to x0 is said to be singular point of the equation, same equation, this equation number 2, if either p of x or q of x or both, okay, are not analytic. Not analytic, that means infinite. Okay, so you have to just remember analytic, that means finite, and not analytic, that means infinite. But actual definition of analytic already we have studied, but for the example you have to just remember analytic, that means finite, not analytic, that means infinite at point x is equal to x0. So whenever we have this equation, after dividing the coefficient of y double dash, if we will get this equation, in that for any point x is equal to x0, if px and qx both will be finite, that means analytic, that point is ordinary, and either of these two or both not analytic, that means infinite, so that point is called singular point. So we have two type of points are there, singular point and ordinary point. Okay, now we have two type of singular point. So there are two type of singular point. Number one, regular singular point. That means we can say that RSP. What is the definition of regular singular point? So a singular point x is equal to x0, because this is the type of singular point. So singular point x is equal to x0 is said to be RSP of the equation, this same equation, if both, now here we are not considering p of x, we just multiply p of x by x minus x0, that means this, and x minus x0 whole square into q of x are analytic at x is equal to x0. So if this both function will be analytic at x is equal to x0, then this point is called regular singular point. And second type is irregular singular point, that means ISP. Just same definition, just you have to remember that x minus x0 into p of x and x minus x0 whole square into q of x, both will be analytic, then RSP, and either of this or both not analytic, either this x minus x0 into p of x or x minus x0 whole square into q of x, or both are not analytic, that means infinite, so that point is called ISP. So we have four definition: ordinary point, singular point. Singular point has a two type: regular singular point and irregular singular point. So whenever question asked, you have to just concentrate which point you have to find, or it is already asked that classify that given classify the points, that means classify the singularity, that we have to find each and every point, ordinary point, singular point, and if it is singular point, then we have to find RSP and ISP, you have to check. So I have just make one chart for you, that you have to just remember this chart, and this chart will help you to solve the example. So we have this question. Okay, so first we will take p of x and q of x out of this question. So just taken. Now we have to check for at x is equal to x0 point. Just take any point, x is equal to 0, 1, minus 1, 1 by 2, any point, and put in this p of x and q of x. If both the points are finite, p of x and q of x both are finite, that means analytic, so that point is called ordinary point, simple. But if same point at x is equal to x0, same point, either p of x or q of x or both are not analytic, that means infinite, so that point, this point x is equal to x0 is called singular point. Now if this point is singular point, so now we have to check either it is regular singular or it is irregular singular, that means it is RSP or ISP. For that we have to find these two values, x minus x0 into p of x, x minus x0 whole square into q of x, that means that I just denote this both by a of x and b of x. So if a of x and b of x both will be finite or analytic, that means this point x is equal to x0, which is singular, now it become regular singular point. And if either a of x or b of x or both are not analytic, that means infinite, so this point, that singular point, become irregular singular point. So we have this chart that you have to remember, okay, only, and this will make you remember each and every definition of ordinary point, singular point, regular singular point, and irregular singular point. So this chart will help you to solve example. Okay, so let's start with the example. First example, find singularity of this equation. Only it is asked singularity, that means you have to find each and every point, ordinary, singular. If it is singular, then classify them into RSP or ISP. So first we will start with this equation. So here we have this equation. Now as I told, we have to make coefficient of y double dash 1. So we will divide this equation number 1 with this x cube into x minus 1. So divide equation 1 by this. So we will get this equation y double dash plus if we divide this, so this will be cancelled out and 3 by x cube. In similar way, 7x divided by this, so x will be cancelled out. So x square into x minus 1 in denominator. Now here we have what is p of x and what is q of x. So this is our p of x and this is our q of x, capital P of x and capital Q of x. So we'll just write down. Now first decide at which point this function becomes infinite. Okay, that points become singular point. Simple, because infinite, that is not analytic. Either of these two is not analytic, that means that point become singular point. So by observation we can see that if we put x is equal to 0, so p of x and q of x both will be infinite, that means not analytic. And similar way, at x is equal to 1 also this q of x is not analytic. So we can say that at x is equal to 0, p of x and q of x both are not analytic, and at x is equal to 1, q of x is not analytic. And as we know that either of these two or both will be not analytic, then that point are known as, that means x is equal to 0 and 1 are singular points. Now these are the singular points. Other than 0 and 1 there is no any singular point, because for any value of x this p of x and q of x never become infinite, okay, other than 0 and 1. So all rest of the points x belongs to R, but other than 0 and 1, so x belongs to R other than 0 and 1 becomes ordinary points. So we have so many ordinary points but limited singular points. Now we have x is equal to 0 and 1 are singular point, so now we will classify them into regular singular point or irregular singular point. So for first we will check with, for the x is equal to 0. So now for x is equal to 0 we will find x minus x0 into p of x, this one, and x minus x0 whole square into q of x. So we will find these two value for RSP or ISP, and as we know that we given the name a of x and capital P of x and capital A of x, these two value. So first we will find capital A of x is equal to x minus x0 into P of x. This is our x0, x is equal to x0, so we will put here, so x minus 0 into this. So we have x into 3 by x cube, so by cancel out this we have x by x square, 3 by x square, sorry, 3 by x square. This is our A of x. Similar way, we will find p of x is equal to x minus x0 whole square into q of x. So x minus 0 whole square, and what is the value of q of x? Already we know. So this become x square. So x square cancel out. So we have 7 upon x minus 1. Now we have both the value a of x and b of x. Now we will put this value x is equal to 0 in this two answer. So if we put x is equal to 0, this become infinite and this become minus 7. This is finite but this is infinite, and we, as we know that from the chart or from the definition, either of these two become infinite, then this point is called ISP, irregular singular point. Same to same we will check for the x is equal to 1. For x is equal to 1, first we will find a of x, that means x minus x0 into p of x. Now we will put x0 is equal to this one, so x minus 1 into this, so we have 3 into x minus 1 upon x cube as it is. Similar way we have b of x, x minus x0 whole square into q of x. We will put x0 is equal to this one, and by cancel out this we have remaining 7 into x minus 1 upon x square. So now we have this our a of x and b of x. In this we will put x is equal to 1. So if we put x is equal to 1 here, so 1 minus 1 0, so 3 into this becomes 0, and similar way this also becomes 0. That means both are finite. 0 is finite number, okay, it is not infinite, so both are analytic. So for at x is equal to 1, these both are analytic, so x is equal to 1 is regular singular point. So this is the process how to find singularity. Okay, it is already mentioned in question, find singularity. Now we have one more example. This is already asked in GTU examination 2019, that classify ordinary points, singular points, regular singular points and irregular singular point if exist. Okay, so whatever they exist, you have to find for the differential equation this. So first, same, we will start with the equation, and as we discussed that we have to make coefficient of y double dash 1, so we will divide this equation 1 by x. So we have y double dash plus 1 by x y dash only. So this is our p of x, because we know that we have y double dash plus p of x y dash plus q of x y is equal to 0. That means coefficient of y dash is our p of x and coefficient of y is our q of x, but here y is absent, so q of x becomes 0. So we have p of x and q of x. Now by observation again, if we put x is equal to 0, this p of x become not analytic. That means x is equal to 0 is the only singular point. So we have x is equal to 0 is the not analytic. So x equal to 0 is the singular point. And remaining all the point are ordinary points. So x belongs to r minus 0 are ordinary points. Okay, this is our singular point. Ready? Now x is equal to 0 is singular point, so now we have to check rather it is regular singular or irregular singular. Okay, so for x is equal to 0, first we will find a of x. So x0 is our 0, so by cancel out this x we have 1, and similar way we have p of x, x minus x0 whole square q of x, and q of x is 0, so entire p of x is 0. So now here we have to put the value of x is equal to 0 in these two answer, but we don't have the x, we have direct answer, that means finite answer 1 and 0. So at x is equal to 0, both the value are analytic, that means finite, so x equal to 0 is regular singular point. It's not necessary that each and every example has a regular singular point as well as irregular singular point. It is depend on the question. Okay, so similarly we have these examples that you have to solve by yourself by using same concept. Okay, and if you can decide that given differential equation has which point is regular point, which point is singular point and which point is ordinary point, so you can solve that differential equation according to ordinary point and singular point by power series method. So you have to compulsory know how to decide the ordinary point or singular point. And using this lecture, we have second lecture, that means we have the power series solution of ODE near ordinary point, which is lecture number 1, and another lecture, that means power series solution of ODE near regular singular point. Okay, so this is the most important lecture for upcoming four or five lecture. Okay, so please try to solve each and every example. This will help you in next lecture as well as in MCQ test and in GTU exam also. So thank you very much for today's lecture. We'll see you soon with next lecture.